Okay, so in section 1.2, we're going to be talking about solving multi-step equations. That means that you're going to be combining having to add and add and subtract or multiply and divide both of those operations in order to solve for your variable. So let's just do a little review quickly. I should have done this last video, but I forgot. So remember the order of operations. PEMDAS. P stands for parentheses, exponents, and then there's multiply and divide, add and subtract. Remember that when you're solving equations, you're actually doing PEMDAS backwards. So the first operation you're going to do in order to solve a multi-step equation, you're either going to be adding and subtracting something, and then you're going to be multiplying and dividing. But the first thing we have to do in this particular problem, we want to look at both sides, and the first thing we want to do is collect like terms on both sides. So on the left-hand side, I don't have anything to collect, so I'm just going to repeat what that is. But I can add these two together because they're the same kind of term. So if you have 9x minus 6x, the result of that is obviously 3x. And then plus 15, I don't have any other constants on that side to add to that. So now here is the equation I need to solve. All right, remember when I just said that if you're solving, you're actually doing PEMDAS backwards. So again, I want to isolate this term. If I'm going to cover that up, this is what I need to get rid of, right? Well, what's the opposite of adding 15? And the opposite of that would be subtracting 15, and I want to do that from both sides. The first thing, this drives me nuts, when kids don't put this in there. You got to have that equal sign. Put that in there first. Let's work on the left-hand side first. Negative 12 minus 15 is negative 27. And 3x is the only thing left on the right-hand side because 15 minus 15 is 0. That's why we did that. I wanted that on. So now, look at your variable and look at what's happening to x. Right now, I'm multiplying x by 3. In order to undo that, I need to do the opposite of that, which would be dividing by 3. And I'm running out of room here because I have another example right underneath that. So let's look at this. What's negative 27 divided by 3? Well, that answer would be negative 9. And 3 over 3 is 1, so x equals negative 9. Let's check and see, plug it back into this and see if we get the right answer. So is negative 12 equal to 3 times negative 9 plus 15? This would be negative 12 equals negative 27 plus 15. Negative 27 plus 15 is negative 12, and negative 12 equals negative 12, so we know that's the right answer. Okay, that's the first example. Now the next example, if you'll remember from last year, when you have something in front of parentheses, we have to use the distributive property. Remember that one? Well, if you don't, I'm going to reveal. Okay, so I'm going to take this 2 and multiply everything in parentheses by 2 and rewrite it. 2 times 1 is 2. 2 times negative x is negative 2x. And then I have the plus 3 equals negative 8. Sorry. All right, so now I'm going to go ahead and collect my like terms. Well, I can add these two together because they're constants, right? 2 plus 3 is 5, and then I have the minus 2x equals negative 8. So I want to isolate my variable term. I'm just going to put a little square around that. What am I doing right here with the 5? I'm adding the 5 to this, right? In order to get rid of that 5, I have to subtract it. And I'm going to do that So now I have, let's look at the right-hand side first. -5, or -8 minus 5 is -13. 5 minus 5 is 0. And all I have left over here is -2x. So I'm going to look at my variable. I want to isolate this. What am I doing to x right now? I'm multiplying it by -2. The opposite of that would be dividing by -2. Obviously, x is by itself now because -2 divided by -2 is 1. And you're going to go, oh no, 2 doesn't go into 13 evenly. Well, you know what? I know that negative divided by a negative is a positive. I'm just going to leave my answer as an improper fraction. X equals 13 halves. Okay, so now let's look at a word problem. Try and position this so you can see it while I'm reading it. Okay, your school's drama club charges $4 a person for admission to a play. The club borrowed $400 to pay for costumes and props. After paying back the loan, the club has a profit of $100, and you have to answer how many people attended the play. Okay, so first of all, let's look at what we know. We know what the admission price is for the play. We know what the loan amount was, and we know what the profit was, right? So we need to write an equation so that we can solve this solve this word problem. So if I take the ticket price and multiply it by the number of attending, that's the total money that I've taken in for this play, right? Well, we know what the ticket price is. It was $4. We don't know the number of attending, so we know that that's my unknown. We're going to call that X. We know the loan amount. You're going to take the total amount of money you got from the attendance of the play. You're going to subtract what you have to pay back for the loan, which is $400, and that leaves us a $100 profit. Now I have an equation that I can solve. Remember, if you're solving, you're going to do all your adding and subtracting stuff first, because remember, I want to isolate the variable term. So that means I need to get rid of this, and the opposite of subtracting 400 is adding 400. Do that to both sides, and now I have 4x equals 500. And what am I doing to my variable now? I'm multiplying by 4. The opposite of multiplying by 4 is dividing by 4. I'm going to do that to both sides. And 500 divided by 4 is 125. So that means 125 people attended this play. And that's how you do the word problem. That's it for 1.2.